Today's class I am going to discuss about how to implement NAND gate by using NOT gate. So first I draw the NAND gate symbol. So it has two inputs A and B. The output is Y. So Y equal to A dot B the whole bar. So it's a NAND gate Boolean expression. Now we implement the NAND gate by using NOR gate. So A dot B double bar. So you just apply the De Morgan's theorem in this equation. So break the bar, change the sign. So A bar plus B bar the whole bar. So here I first made A bar value, then B bar value. So using NOR inverter. So it's a symbol of NOR inverter. So inverter input is A. First terminal input A and second terminal input also A. The corresponding output is A bar. So this concept we discussed earlier video. If you need it, kindly refer the video. Then come to B bar. So how we obtain the B bar? Using another NOR inverter. So input is B, output is B bar. Then these two output values are given to input of another NOR gate. So the third NOR gate output is A bar plus B bar the whole bar. But we obtain this equation in terms of NAND equation. So here I am using one more NOR gate. Now the final output is Y. So Y equal to A bar plus B bar, then double bar. So this expression is equivalent to A dot B the whole bar. So how this expression is equal to A dot B the whole bar? Let me simplify the expression. First you simplify the internal bar. So apply the De Morgan's theorem. De Morgan's theorem. So break the bar, change the sign. A double bar dot B double bar the whole bar. So here this bar cancel. Then you get A dot B the whole bar. So this expression is equivalent to A dot B the whole bar. This is a method to implement the NAND gate by using NOR gate. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.